In today's video, we will be learning about how to recode the multiplier and use it while performing multiplication using modified Booth's algorithm. Here is a simple table and here we are assuming some multiplier bits. For example, in our problem, we'll have some multiplier bits maybe in this form 1, 1, 0, 0, 1, 0, 1 and so on. Likewise. So what we are doing now, we are considering 3 bits. This bit will be the ith bit and here this is I plus 1 and the previous value is I minus 1. So likewise we are considering 3 bits now. So here are those 3 bits, ith bit, next bit I plus 1 and previous bit I minus 1. Likewise we are considering 3 each. For the next set of combination we will be taking the next 3 bits like this. In our example, so what is a maximum combination if you assume 3 bits? It can start from 0, 0, 0, 0, 0, 1, 0, 1, 0, ends up with 1, 1, 1. These are the maximum possible combinations. Therefore, whatever the input may be, right now we are trying to form a table with all possible combinations of 3 bits each in multipliers. So the first step we have to do is we have to consider this bit as the ith bit, one after that and one before that we have considered. So what we have to do, we have to check the transition from one bit to the other and recode the value. This is a simple Booth recoding procedure. In order to do that, we have to remember whenever there is a transition from 0 to 0, the recoded value will be 0. Whenever there is a transition from 1 to 0, the recoded value will be plus 1. Whenever there is a transition from 0 to 1, it will be minus 1. When the transition is from 1 to 1, it is again 0. We have to remember this in order to recode. Okay. So now there is a shift from 0 to 0. So the recoded value will be 0. From I to I minus 1, the next shift also it is transition from 0 to 0. Therefore, the recoded value will be 0. In the same way, we have to recode the remaining bits also. When there is a transition from 1 to 0, it is plus 1. When it is from 0 to 0, it is 0. Coming to the third option. When there is a transition from 0 to 1, it is minus 1. From 1 to 0, it is plus 1. Fourth combination, there is a shift from 1 to 1, therefore it is 0. There is a transition from 1 to 0, therefore it is plus 1. The fifth choice, the transition is from 0 to 0, therefore 0. 0 to 1, therefore minus 1. If there is a transition from 1 to 0, it is plus 1. For 0 to 1, it is minus 1. And here, the transition is from 0 to 1. Therefore, it is minus 1. Whenever there is a transition from 1 to 1, it will be 0. Again, it is 1 to 1, 0. Another 1 to 1, therefore 0. So, these are the Booth equivalent recoded value of the multiplier for these input combinations present in the multiplier. So, whenever in the input it appears to be like this. If this is our multiplier, instead of using these 3 bits, it is enough to recode using Booth multiplier as 0, 0. This is a recoded value. Right now, we have to calculate the weightage for these values. So, for the combination 0 and 0, if this is a pair, what will be the weightage? Both are the base of 2. So, this should be 2 to the power 0, 2 to the power 1. 2 to the power 1 means 2 into what is the value here? 0 plus 2 to the power 0 is 1. 1 into 0. Again, this is also 0. This is also 0. When you add together, it results in 0. Therefore, the multiplier value at this location, it's going to be 0. And for the next combination, it is 0 and plus 1. Therefore, it is 2 to the power 0, 2 to the power 1. So, 2 into 0 plus 1 into 1. 2 to the power 0 is 1 into here it is plus 1. This results in 0. This results in 1. 0 plus 1 equal to 1, which is nothing but plus 1. Now the other combination, plus 1 minus 1, therefore this should be 2 to the power 0, 2 to the power 1. So 2 into plus 1 plus 2 to the power 0 is 1, 1 into minus 1. So 2 into 1 will be 2, 1 into minus 1 will be minus 1, therefore I am making it as minus 1. 2 minus 1 is 1, it should be plus 1 again. So this is plus 1. And what about plus 1 and 0? Again it should be 2 to the power 0 and 2 to the power 1. 2 into 1 plus 1 into 0. So this becomes 0, this becomes 2. So 2 plus 0 equal to 2. So it is plus 2. For the combination minus 1 and 0, 2 to the power 0, 2 to the power 1. So 2 into minus 1 plus 1 into 0. 2 into minus 1 becomes minus 2 plus 1 into 0 becomes 0, which is equal to minus 2. So this location will be minus 2. So next combination is minus 1 plus 1. So again 2 to the power 0, 2 to the power 1, 2 into minus 1 plus 1 into 1. 2 into minus 1 is minus 2 plus 1 into 1 is 1, which becomes minus 1. So this value is minus 1. And next we have 0 and minus 1. So again 2 to the power 0, 2 to the power 1, 2 into 0 plus 1 into minus 1. 0 minus 1, which is equal to minus 1. So the value will be equal to minus 1. If it is 0 and 0, we have already worked out the output is 0. So again the multiplier value should be equal to 0. So the same content is being repeated in the next slide. So here is a clear form of the table. Here are the possible input combinations of multipliers, and we are recoding using Booth recoding logic. We have recoded to some form and reduced the number of bits, and later we pair these two values together and found one equivalent weightage for these two bits. So what is happening? Instead of using so many bits, it is enough to use only one bit for representation. This particular value will be called as bit pair recoded multiplier value. So what happens in the problem when we are multiplying using modified Booth's algorithm? Instead of using the original multiplier, we will be recoding the multiplier to this form and then multiply with the multiplicand. So in order to obtain the partial product, this is a multiplier, equivalent multiplier value 0, which will be multiplied with the multiplicand m. Similarly, we have to multiply the multiplicand with plus 1 in order to obtain the partial product. So this is how we have to write the complete table, and we can have this as a backup while performing modified Booth's algorithm problems. I hope the explanations are clear. There are lot of examples being solved, and the link for all solved examples are given in the description box. Thank you so much for watching the video.